Okay, the purpose of this video is going to use the example in our Cornerstones 4th E cost accounting textbook to explain this statement here, or at least to illustrate it, why we can reduce ABC systems and reduce the number of cost pools and they can still be effective. Okay, here's what it says here. It says it's always possible to find a reduced system that matches the accuracy of a larger ABC system, and we can do this by reducing the number of cost pools. So here's what they ask. They say form a reduced systems cost pool for activities 3 and 8. Okay, so activities 3 is testing, 8 is purchasing materials. And here's what we do. We look at the ABC assignment, right? We've got 800,000 assigned to wafer A and $1.2 million assigned to wafer B. So the total of those costs are $2 million. But we want to reduce the system cost pools. So the first thing we do is we calculate the ratio. We take the 800,000 divided by the total, right? These are our cost pools. And then we take the $1.2 million divided by the 2 million total. So we're originally starting off with these 4 different activities. Here's our total cost pools. Well, if we do this calculation, what we come up with is the equation that you see here. Now, they give us the expected consumption ratios. Okay, so this work had to be done for us ahead of time. 0.6 and 0.2 for wafer A, and 0.4 and 0.8. So if we take the 0.6 and the 0.2 and we equal it to the wafer A percentage, which was the 40%, right? 800,000 divided by 2 million. And then we take the 0.4 and the 0.8 given here and set that equal to the wafer B percentage, which was $1.2 million divided by 2 million, or 60%, we have our equations. Then we have to solve both sides to determine wafer 1 and wafer 2, and what's that proportion we need. All right, so if you look here, you can see how I did the math to solve this. I set up those equations. 0.6 plus 0.2 equals 0.4 for wafer A, 0.4 plus 0.8 equals 0.6 for wafer B, and then what I do is I multiply 4 times the first equation, bring down the second equation, and subtract the 4 from the first equation. Okay, so when I do this, or actually let me say this again, I multiply 4 to the first equation. That gives me 2.4 W1 plus 0.8 W2 equals 1.6. Then I bring that down, and then I subtract the second equation from it. Here's the second equation. When I do that, since 0.8 W2 minus 0.8 W2 causes W2 to fall out, I'm left with 2 W1 equals 1. Solving for W1, I get 1/2. Now, then I plug that into the second equation, right? 0.6, or I can plug it back into the first equation, is 1/2 for W1 plus 0.2, right? I'm using this original calculation, and I solve W2 equals 1/2. Okay, so that's the math involved that you have to go through. All right, so if we slide back here, that's how we got the 1/2, 1/2. Then we can answer that reduced pool by taking 1/2 of the 2 million. Now we're down to $1 million for both the product cost pool and the purchasing cost pool. And let me correct that. That's the testing product cost pool, right? That means this one, activity 3 and activity 8. Okay, so then it says assign the cost of the reduced cost pool. So what you would do is you take the 0.6 times the 1 million. And remember, the 0.6 is what was given here, and the 0.4, or excuse me, 0.6. Yeah, we take the 0.6, it's given for wafer A for testing, and then the 0.2, which was given for purchasing, times the million, and we see now we've reduced the cost pool for that to 800,000. For wafer B, we use the 0.4 and the 0.8 given, and we've reduced the cost pool to 1.2. Okay, so that shows you how we can reduce the calculations and still get some accuracy. Now, they then ask you to repeat it for step 3, which I'm not going to do because it's just a repeat. But what's the implication of all of this? Okay, that's what we see right here. Let me slide this over so we can see this. Okay, what this does is it attempts to show that an equally accurate simplified system can be derived from more complex AB systems. So instead of using 12 drivers, it's possible to use only 2 drivers and achieve the same cost assignment of more complex systems. So that's the whole goal. We want to reduce cost pools, we want to reduce drivers, and still get accuracy from our ABC system.